Yeah, so let's go through two examples. Okay, so the first, this is we're doing arithmetic and sequences and series. So I'm going to write down two examples here. Example number one, I start off with the number 3 and I add 4, let's say 7 plus 4 is 11 plus 4 is 15 plus 4 is 19. And I continue in that fashion up till a certain number, maybe not sure yet. Okay, so we can just leave it like that for now. And let's say example number two, I start with 11 and minus 5. I get 6 minus 5 is 1, minus 5 is negative 4, minus 5 is negative 9, minusing 5 every time.
Mm-hmm.
Okay, now the first question they're asking me is they say, find the nth term of the sequence. And we're looking at, let's say, example number one. And
Mm-hmm.
then, so if we want to find the nth term of the sequence, this is what we got to do. So example one, I've got 3, 7, let me write it below here. 3, 7, 11, 15, 19. If I want to find the nth term, what I can do is use the general formula to calculate the nth term of any arithmetic sequence, which is Tn, term n, is equal to a, which is your first term, plus the common difference d, in this case it's plus 4, minus 1 multiplied by n. And this is something that is normally given in your formula sheets. So you'll get that there. My a term is going to be equal to 3.
Mm-hmm.
And my common difference is the number that I'm jumping across by. So that's plus 4. And that's d. Whatever number it's a common difference. We also know that this is term 1. This is term T2. This is T3. T4. And I'm trying to find the nth term in terms of n.
Yeah.
So I can find any term if I change n. So using this formula and a equals to 3, I can get my nth term to be 3 plus d is 4, so that's 4 minus 1. And n stays n because we want it in our formula. So this becomes 3, 4 minus 1 is 3, and your nth term is 3 plus 3n.
Yeah.
Okay. The next question they say, okay, now that you have that, find the 100th term. So in this case,
Multiply by 100.
you would basically find
Mm-hmm.
you find t100 basically. That's what they want you to find. So you say t100 is equal to 3 plus 3 and replace n with 100. You can see they correspond, the n and the n.
Yeah.
And t100 or term 100, the 100th term will be 303. Okay. The next thing they can ask you, or they ask, is which term. They ask you which term. Question 3. Which term of the sequence equals, and they give you a certain value they want you to calculate. All right. So let's say 453. Which term equals 453? What you're doing for this one here is they actually asking you to find the nth value.
Mm-hmm. Where t is equal to 453.
Yes. So then we replace. So therefore, we're saying for this one here, we're saying Tn is equal to 453. Find n. So we take our nth term and we make that equal to 453, and that's equal to 3 plus 3n. I then subtract the 3 on the other side, times 450, and I divide by 3, giving me n equals to 150. So the 150th term will equal 453. Okay. And this is all
Yeah.
this is mainly part of sequences because we're not adding it up or subtracting it, etc. Now, built on the same concept, keeping this in mind, I'm just going to write it here somewhere on the side here. So we got Tn equals 3 plus 3n. I'm just going to keep that handy. We know that T100 equals 303. And I know that T150, I'm just going to write it here because I'm going to erase all this, equals 450. And we go on to question number 4 now. Question number 4, they want us to find the sum of the terms. Okay, so they're saying, find the sum of the first 50 terms. All right, so question number 4, find the sum of the first 50 terms. Now, if that's the case, we're basically now using a new formula, and this formula is called Sn, which is the sum of n terms. Also given you in your formula sheet, and it's formula driven. The formula looks like this. It's n over 2 multiplied by 2a plus n minus 1 times d. Now, with this here, my a value, remember, is still 3, and my d value, or my common difference, is 4, because I'm plusing 4. So my sum to n terms is going to be given by substituting a as 3 and d as 4. And that becomes n over 2, 6 plus 4n minus 4. 6 minus 4 is 2. Plus 4n. And I divide everything by 2, multiplying n in. I get n, that cancels with that. 2 goes into 4 2 times. That becomes n squared. So 2n squared. So this will be the sum of n terms for me. I can double check it. Let's say I add the first 2 terms. It must add up to 10, right? So if I make this 2, I get 2. 2 times 2 times 4 is 8. So 2 plus 8 is 10. That works.
Yeah. So for 50, you just substitute 50.
Yeah.
So you go 50 plus 250 squared.
Yes. So that's what we're going to do now. We're going to change that, and we're going to say for 50, we put 50 plus 2 times 50 squared. That's it. So let's write that in there. We get S50 equals 50 plus 2 times 50 squared. Put it on your calculator, and what will that give you?
2 times 50 squared. We get 5,050.
5,050. And that's the sum to 50 terms. All right. Now, the next one says, okay, well, for what value of n will the sum equal a certain number? For what value of n will the sum? So let me just write it there. For what value of n will the sum equal a certain number? All right, so let's say 210. So in this question here, question 5, I'm going to make the sum equal to 210.
Now you just substitute Sn
That's
for 210.
that's it. So Sn becomes 210. So that gets me 210 equals n plus 2n squared. And now I've got to solve for this. So I make this 0. This becomes 2n squared plus n minus 210. Trying to factorize this now. We got definitely 2n, and n gets me my first term when I multiply it. And then 210, got to break it up into two numbers such that, so if I go through it, I mean, I got 3 times 70, but 70 minus 3 will not get me 1. So it's definitely, I've got to pick up this number and I've got to drop this number so that they're very close to each other or more closer than that. And I've also got this 2 to take into account as well. So if I look at factors of 210 on a large scale, I got 3 times 70. I've also got 21 times 10. I've also got 5 times 42. If I'm factorizing this, I could do that. So if I go with 21 and 10, I can see that if I multiply this by 2, this will become 20. And then 20 minus from 21 will get me 1. So that's the factors I'm looking for. Factorizing here is important. So we're looking at 21 and 10. I've got to multiply the 2 by the 10 to get 20 in. And I've got to also multiply this by 21. That's 21 in. And when I subtract this, I've got to make this a plus. I've got to make this a minus. So n can equal negative 21 over 2 from here. Or
It's
n,
just 10.
which is not, this is basically not applicable. And then n equals 10 definitely is the solution there. So this is not applicable. And that's how I find that nth term for that.